Thanks, everyone. Okay, so, yeah, I work at Buzzfeed. I want to be this person when I grow up. This would be amazing. Great socks, great life. But for the moment, I'm just working as a developer on the front-end infrastructure team in London. And one of the tasks, I've been there about 2 years, and one of the tasks that we took on in that time was figuring out how to test our analytics systems. And so, a disclaimer, this is a pretty specific topic. But really, this is kind of a case study of approaching quite a tricky, challenging problem that pushed me out of my comfort zone. And I think we can all kind of relate to that with things that we work on, or that hopefully that we get to work on now and again. So it should be pretty useful still. So within this, we're going to cover why and how we use analytics at Buzzfeed, how we used to test analytics, this moment of intense head scratching as we figured out that that wasn't very good and we should figure out how to do it better, and then now how we actually do test analytics. All right, let's kick it off. So why, anyway? Well, so BuzzFeed has been around for 12 years now, nearly a teenager, and they're convinced that they were successful and survived through this last 12 years because they understood their audience better than many other publishers, many of whom were coming from a print background. So we're really into this feedback cycle. So up on the left, we have our editors who are creating. They're the people who really the true talents of BuzzFeed, and they create inside the CMS. We publish it to our users, and then we collect that, store it, and then we can put it on nice iPads and stuff. But the bit that we really care about is the bit in between there, the learning part, and how we get our analytics into the CMS, where we can meet the creative talent with our insights about the audience, and then create even better content that helps to engage more, helps to go viral, all that kind of stuff, all that good stuff. So another thing that I want to just, before I go any deeper, is to explain this word pixie dust, because I'm going to use it a lot during this talk, and pixie dust is our analytics pipeline. It's kind of sprinkled all over our infrastructure and all our websites and mobile apps and all that kind of stuff. At the simplest level, it's just a 1x1 GIF with a bunch of query strings on the end, and then at the slightly more complex level, there's all sorts of things happening behind the scenes. All right, so how we used to test analytics with end-to-end tests, this kind of whole thing is based around that. Well, the fact that we even have to have the title how we used to means that there was an outage at some point. So this, with all our outages and postmortems, the first thing we do is we look at timelines, and it was actually really useful. We still have all these saved, and I went back and looked at them for this talk and could figure out all the stuff that I'd blocked from my memory when we finished this project. And so this really happened, it started in May, June 2016. We had a few tiny outages of analytics, so maybe we stopped tracking for an hour, maybe one small event that we want to publish start coming back. By themselves, they weren't a big deal, but collectively it kind of added up to people thinking that we weren't really on top of this stuff, that the ecosystem was a bit fragile, and people were just a bit frustrated with it. And then in July, we had a bigger outage, and this was a 2-day outage where Safari wasn't sending back page view events to either Google Analytics or Pixie Dust. And this was irrecoverable. It was a big deal. People were pretty upset about it. And shortly after this, we were told to fix it. So what actually happened here was we used to use a third party called Soaster and their Impulse library, which tracks the real user performance metrics of our users and beacons it back. And they released an update to their script, which we bring in dynamically. And that was one half of it. They released a bug. The other half was we had some really bad code around error catching. And when we caught the error, we just bailed on all analytics, which is, in retrospect, quite stupid. But, we fixed that. But yeah, it was a big issue. So we go away and fix it, we were told. And I wanted to explain how we actually used to test it anyway. So when you go to our site, when you request the page, we load the HTML, we load the CSS, and we load the JavaScript. Inside that JavaScript bundle, we initialize all our application code, and somewhere in the application code, we make a call out to this to like track. We say track page view maybe when we load the page, when it's actually loaded. And that track goes to something called BFA, stands for BF Analytics, and this is kind of our abstraction on top of a bunch of other analytics libraries. So Google Analytics, Pixie Dust, Quantcast, Comscore, and many others. And BFA kind of describes how one event should map to many events. And so the idea is then you track in one place and multiple vendors receive your data. This is like a really annoying abstraction, BFA, but one that we don't really have much of a better answer for at the moment. Like when I was back at Lonely Planet, we wrote the same thing. We have it at Buzzfeed. I imagine some other people have something similar, something like Segment.io, and I'm always looking for a better replacement for this. So if anyone has a better idea of how this layer works, I'm super interested. But this is tricky to test anyway. That's going back to the actual point of this, rather than me just trying to find out how you do this. So how do we test analytics, right, with end-to-end tests? So typically in an end-to-end feature, let's say like we want to log in, you would go to the home page, maybe click on the login button and assert that you see a form, right? That's like kind of standard and reasonably easy, but there's something to assert on, something visual that happens. With analytics, there's nothing to see. Like it just goes off into the ether. It's a network request, but that's it. So the way that we had solved this prior to this project was we had built something into BFA which moved those network requests into session storage as well. So when we made a request to like fetch Pixie Buzzfeed with a type of page view and a source of web, in session storage you had something that looked like this, which kind of described those requests that had gone out. And then we used our tests to figure out if they were correct. It's not ideal. We're already kind of bending how end-to-end tests should work. It looked a bit like this. We open a pull request. We start this test. It goes to Source Labs, or we spin up a couple of different browsers. We go to 3 or 4 pages. We share something. We look inside session storage and assert that all these values are here. And then we give a green or a red at the far end. And because we're bending how end-to-end tests should work, the tests were super flaky. And I'm sure all of you have experienced flaky tests. To be specific about what this means, like we're talking about non-deterministic tests. So if I run 10 tests 10 times, they should be 10 fails or 10 passes. And that's the ideal case. And in reality, we've all been in a situation where 7 and 3, 5 and 5, whatever, blah, blah. And this is actually really bad. This is a really bad problem, because what typically tends to happen is, well, first people start to blame the tests and they get angry and frustrated when things time out. Secondly, they disable the tests. And then thirdly, they don't put them back on, right? So then 6 weeks later you check and like, oh, the test has been off for like 6 weeks. That was lucky. And I've done it, like I'll hold up my hands. But yeah, this is a bad problem, because we were like bending these tests to be something they weren't. We were running into this more often, and it was harder to make this good. Plus, anyway, bugs still reached production, right? We'd already had these outages. So it's not like these were perfect. When we were catching them, they weren't really testing that a network request went and left the page. They just tested that something went into session storage. And bugs could still appear in production because we're only testing when we put them into prod. We're not testing that like Soaster breaks some third-party JavaScript, which then changes production. So those were that was the state at the time and the problems. And then the next part was this bit. And this section, I think, probably took, conservatively say, 3 months of just like working different things, but having this in my head all the time. There was 2 of us working on this, but we were kind of juggling a few things. So to be specific about what we wanted to validate that core metrics, core analytics events are captured when someone goes to a page. So for us, that's page views, page exits, so we can marry those up, and share events. There's a few other things that we track, but we don't really care about those too much. Those are the 3 big ones. We want to check that the correct values are sent with those. It's not good enough that we just say there's a page view. There has to be like a URL with it and bits and pieces, and to help us like marry them up at the far end. We need to make sure the requests are actually made, not just in session storage, and that we only send them once, because that was Like getting duplicate events through is a problem we've had a few times, and that can be as bad as having none sometimes. It takes a long time to figure those things out, dedupe them, and it's a lot of effort, and do you really care too much? So what we wanted, and our requirements on the other side were, this should be cross-browser. Like the big outage was in Safari, but it could easily have been in Chrome. Non-flaky tests would be ideal. This is a good table stakes baseline to start with. We want to prevent bugs reaching production. I want to catch bugs that appear in production, and we want to be notified immediately when any of these bugs occur. Which seems an aggressive number of requirements, but it's not too much to ask, I don't think. So we listed out some options. This was kind of spitballing, we didn't really know. So you can have some Selenium tests which actually test the network requests go out. There are certain plugins for things like WebDriver IO, which we were using, which can do that. But they have to initialize before you send the requests, and you end up with race conditions, and it doesn't help flakiness. It just flat out doesn't. We tried for ages. There was no way to really make them deterministic. We thought about using service workers to intercept the requests, because that actually is proxying real requests that get sent out. That was also kind of flaky and a bit difficult to handle, although we ended up turning that into a developer tool, which you can run and make sure that your page is sending requests correctly. We thought about just enforcing you have to use QA in stage. Not really very scalable, plus the production traffic from real users is very different to our stage traffic. That didn't really fly. Plus, stage for us isn't really an explicit path on the road to production, so there's no gate for us to promote stage to prod. You can just skip it. And we thought about just using production monitoring. That would be fine. We'd catch things pretty quickly. We do have some of that already in place. Every 4 hours, we run a script which analyzes the number of events that went into GA and the number of events that went into pixie dust, and make sure they're within a 2%, 3% threshold. So we can notify that, but 4 hours is a bit too slow for us in this kind of scenario. And to speed that up, we would have to take into account trends, because we have quite spiky traffic. If a post is very viral, we'd have to pick a page that had stable traffic. Not impossible maybe, but pretty difficult. All right, so the most important slide. There's a book by George Pollier called How to Solve Anything, which I bought but didn't even read because I was too focused on this thing. But the first one I think is one of the most important. Just bug your colleagues incessantly. Someone has had this problem before, or someone has been involved with somebody who solves something like this. I asked literally everybody, talked on Twitter, went to meetups like this, talked to many people you can, to see if you have one little spark of information which triggers something, because you're letting all these thoughts percolate in the back of your head all the time, and sometimes it can just take 1 or 2 words. Work on something else. We did that a lot, mostly because we just didn't know what to do half the time with this. So we would go and work on different projects, come back to it. I took a lot of long showers, basically just get some silence, step away from your stuff. Go to Floatworks in Vauxhall and have an isolation tank. Even if it doesn't work, you'll feel good afterwards. And then steal ideas at every single opportunity. And that's actually kind of what we did for this, which isn't a great story. But at the time, there was 3 of us in the London office, and we were hiring for the 4th. And I was interviewing a guy called Mark, who now works with us. And I took the opportunity just to ask him how he does end-to-end testing at their job. And turns out they do something really good. They worked at Halo at the time, and they have a real island, but it's uninhabited, and they put fake cars on it and fake people, and then they have robots going around. And they realize if none of the fares go up, or if the fares suddenly go 300x, or the fares stop happening, that something's probably broken. And I was like, that's interesting. So you're kind of production traffic, but synthetically managed. And it got me thinking that maybe we could do something like that. And we hired him. Not related, but yeah. So how we now test analytics. So when we started thinking about, okay, what if we just think about production? We realized that we can't do this pull request thing anymore. It would still be really nice to do on the pull request, but we couldn't find a way to make the test non-flaky. And because bugs will happen in prod anyway, we're going to have to solve that problem. So let's solve that problem, and maybe we can figure out later how to do the CI problem. So we got rid of this. So I'll go back a few and think about like what actually is pixie dust. Let's go into a bit more detail. So when the request leaves the browser, it goes to the pixie dust API, which is inside our infrastructure. This stuff isn't super important, but it's just worth painting the picture. And then the pixie dust API passes that off immediately to something called NSQ, so like RabbitMQ or Kafka or whatever. Basically, this is, if you don't know anything about queuing, like that's okay. I don't really either. But it's something like BFA, right? It's the pub sub. So you say, I've got this event from Pixie Dust. If anyone else wants it, you can have it, and you can subscribe to those events, and I'll pass you them. I mean, that's how we get it into the database, right? That's one of the ways in which this stuff goes in the database and then onto the iPad with the good socks. So when we were looking at session storage before, our end-to-end was like the browser to session storage, but really these are the two ends, right? The ends are the database and the browser. I don't really want to go anywhere near the database, like production database, but we still want to test in the browser. Even though it's not going to come from a pull request anymore, we need to make those requests somehow. And we could assert here and make sure that what's in the database like is good, but seems kind of risky. However, because NSQ is this pub sub mechanism, we can add another thing in there which does the assertions. And it's going to say, give me all the events to do with page views and page exits and share events. And suddenly you've got this application which is getting this fire hose of events. Which is the same situation if we're using production traffic. And well, it is production traffic, but like all production traffic. It's not that useful to us. It's like, it's nice to hook into, but we don't really have anything right now. But if we can control the traffic that comes in, then maybe we can do. So what we did is we built just a small cron job which runs the tests every 2 minutes. And those tests go to 3 pages, share something on Facebook, and then bail out. And each of them has a unique ID which we can get at the far end. So now, instead of this fire hose of events that's coming into this application, we say, okay, I'm going to ignore everything that doesn't have this unique ID of end-to-end test. So suddenly I just have this trickle of events rather than this fire hose. And within there, we can do the same tests that we were doing before on our, in the CI tests of like, they should look like this. These are the ones that I've got. Are they the same? If they are, or if they aren't, we'll push that off to a dashboard. And also we'll push it off to Slack because we don't have a way of like blocking pull requests anymore. So we have to kind of fill in those blanks of like, how do we communicate back to users that you broke it? Because this is all a one-way street. And this is pretty much like without a few bits and pieces, this is the final solution. And the way that we kind of solved flaky tests fundamentally is by just removing the assertions at the bottom. If you don't test anything, you can't have flakiness, all right? So now it just goes to the website and that's it. That's its job done. So these things run happily in the background. And then we assert at the far end, and then we pipe it into a dashboard that looks like this, which is in Datadog, but it doesn't matter too much. It's just we have the different share events, page exit, share, our different page types, and some different share bars. And this is going every 2 minutes. We run these tests with 3 instances, so we run like 3 concurrently. And then every 5 minutes, we check to make sure we have events that have coming through in that 5 minutes. We do that because we can't guarantee immediate resolution of those events in NSQ. And then if they go wrong, that goes red, but people don't really look at that, but we send it into Slack. And if these goes off, it's usually pretty scary, like everything's broken, or it's Source Labs has gone down. And then it's just a big stream of red, and we know that Source Labs go down, we just go and check the outage, and it comes up 5 minutes later. So anyway, this is kind of the solution. This is where we got. But there are still some issues with it. So because we've taken it off the pull request, we don't really have a great way of reassociating bugs with the commit that happened. And maybe we can find the commit or the deploy, but the person and then getting them in Slack is tricky. So we're just quite noisy with our alerts. Like something broke, you should probably pay attention to this. We do depend on third-party source labs, and if it goes down, our tests go down, but you can correlate them pretty easily, and the downtime's not so bad, really. Plus, we don't really care about latency. Like, sometimes with source labs, the tests can be slow, it's kind of annoying, but we can just run more of them, and it doesn't really matter how long they take. So we found that like booting up like iOS, which is one of the things we test on, so like when we went to iOS 10 or whatever, changed from a minute to like 5 minutes just to boot up the phone. But it was fine, we just added a few more and they just run a bit different speeds and it's all good. We still have no coverage during development. Like we had this service worker kind of hack, but we deleted it recently because we just weren't investing enough time into it. So, I don't know. It would be nice to solve that problem. We don't have a good answer for it right now, but ultimately the analytics are working, so it's all good. And we have no coverage of anything that's not pixie dust because this is really specific to pixie dust. The fact that we can get to the other end of that network request is something we can't do with anything else. So we're a little bit exposed there, but ultimately pixie dust is the source of truth for us, so that's not too bad. I don't know, what did we find out? Well, we had a lot more bugs than we knew. Like once we started properly testing end-to-end, we realized that there was bugs inside the routing in NSQ, in Pixdust API, all sorts of stuff that we hadn't anticipated. Like felt like weeks I was watching this dashboard waiting for it to go green, and it's just like there was more and more things happening that like wasn't quite right. And we found that testing in production has some fun side effects. So this is a dashboard of just a post I picked up like early today. But the main thing about this is this dashboard. This is called Dashboard. It's measuring like the social share effect of a post. So like ideally the red is like way higher, and that means that more people have shared it. And now like because I run the tests on my post, I have the most popular post on Buzzfeed. It's staggeringly successful with 3000x social lift. And this annoys data scientists and machine learning stuff, and surprises people because it just appears in recommendation feeds and we have to like block that up. But anyway, the thing I think that I would take away from this talk, even if you don't go and re-implement Pixdust on your website, is that this thing that I learned from like that conversation with Mark in the interview is like, I was trying to solve this problem using the tools I knew, which was kind of end-to-end testing at the PR level, and we couldn't solve it that way. Like it just wasn't possible, and we were butting our heads against that, and he made me think about it in a slightly different way, which suddenly opened up a whole bunch of new ideas. So I would suggest that, yeah, if you find yourself, you're like reaching the limit of what you're capable of doing with the tools you've got, it's worth just completely throwing away for a second, think about how you could approach it from a different way, and it might work out. That's it, thank you.